Okay, welcome everyone. This is the KubeVirt Community meeting, Wednesday, 2nd of December, 2020. So we have a short agenda so far. Feel free to add any additional items, but so far we have one item from Ryan about thread and discussion on save and restore. Ryan, all yours.
Hey, thanks, Pep. All right, I'm going to share my screen here. Okay. All right, the link for the docs in the community meetings. So we talked a little bit about this last week. We had a number of discussion items. So I just kind of threw three topics in here, but we don't need to adhere to those specifically. Those are just three that I know that some changes that I made, but there's been some discussion on the mailing list as well, and we can cover that too. All right, so I'll go to the doc here and just kind of go over one of the first items. To kind of like introduce this again, like talk a little bit about like use cases, goals, and things like that. And so the first thing is one of the things like that I want to accomplish with this proposal. I kind of titled it. I've kind of tried to sum it up here, like offline virtual machine migration. So essentially, the idea that I can take a virtual machine, I can sort of like put it aside. I can save its RAM. I can save everything associated with that virtual machine. Take its execution, take it down, and then at some point later on, I can then bring it back up and start exactly where I was, and continue off with whatever I was doing. I think offline virtual machine migration is kind of the term that I've seen used, so I figured I'd use it here. It seems appropriate, essentially taking that machine down and moving it somewhere else and using it. So now the use cases kind of generally go along with this. So the idea that an administrator can take a misbehaving virtual machine and save it and investigate it at a later date, maybe in an environment that's more secure, doesn't have internet access, and do some sort of debugging there and making sure or figuring out what's wrong. Another example, in like kind of an appliance type situation where a customer who is using an appliance from a vendor, they don't quite understand entirely what is in this appliance. It's maybe it's broken perhaps, and they need to, they don't know how to fix it because they don't understand entirely what's the appliance is doing. So they can save it, send it off the vendor can look at it, restore it, fix it, and return it. So those are kind of the general use cases of this, and some of what I'm looking for. I have a few definitions, terms here, since I think there's a ton of terms associated with this. And from what I could tell, there's a lot of these terms get different definitions based on platforms and hypervisors and all sorts of things. So I kind of define them here just so that we have a consistent understanding and kind of what I'm talking about was when I say use some of these terms. Pause, suspend. KubeVirt has pause, so essentially temporarily putting a machine on hold, no CPU, network, or disk activity. Unpause, resume, remove that hold on that execution. Save being hibernate or sleep. Virtual machine stops, RAM is stored in a file, shut down. Restore, create an identical virtual machine that was saved during the shutdown, and bring it back up online.
Here I have a question already.
Yes.
Ryan. So it looked to me that you actually would want to pause the VM and then save it, right? From the use cases above, but here it looks like you see save as if you first hibernate it normally and then save to the RAM file. Or
yeah, so
or both.
Yeah, so I'd say I even kind of yeah, so I guess you could say like for both that would be the case. That's fine. I actually think this does that. Like I was looking at this, like when I've done some testing in this, I'm pretty sure that this command in libvirt actually does a pause and then does a save. It's just whether or not what happens afterwards. And that's kind of why we'll put this here. Like this is a live, like the virtual machine stays alive after. That was one of the questions we had last time. Can a virtual machine stay alive after you do a save? And it can. There's a way to do that.
Okay. So, and then you say that using something like virdomain save flags live is not what you want to do. So my main question here would basically be, wouldn't I for the above use cases, wouldn't I just really do a snapshot on how it is at the moment?
Sorry, wait, you said in the above use cases, would I just do what?
So you just meant that when you go down to the acronyms again,
Yeah.
a little bit. You're saying as non-goal, create an API for real domain safe flags. This is just, you mean you don't want to say, don't want to implement live migration, live snapshot, I guess, just to save operational degree. I'm just a little bit, maybe I'm asking the questions too early and you want to go more into maybe I come back to that later. Just go on and explain your stuff. Sorry for interrupting too early.
Okay, no, it's okay. I do want to talk about that. So so the next thing, non-goals, and the reason why I define this here, because I keep hearing live virtual machine snapshot, and so I've kind of explicitly been trying to use the word offline, sort of like an offline snapshot, and what I am trying to say is that the result of the save operation is that the virtual machine is no longer running. And so then the inverse meaning that if I'm doing a live snapshot would mean that the virtual machine stays running after I do the save.
Okay.
And I don't know if that helps, Borman.
Yeah, that helps.
It's the same mechanics, though. We're just saying that for a live snapshot, we go through the same stuff. We're going to pause or suspend and then just save the memory and then unpause it.
But I guess it makes sense from the, well, it depends the live snapshot. I guess this all even goes as far as, if the guest agent is installed, you can really do live snapshot with pretty much no visible downtime, right? So live snapshot is much more complicated. So I guess in general, it makes sense to say that this does not want to implement it, I guess.
Yeah, I get the way I'm approaching it is that a way I look at it is that the sort of the end result, is the virtual machine running, yes or no? And I don't want to end up what I don't want to implement here is where after I do this save or whatever snapshot, we end up with a live virtual machine, a running virtual machine. That's not quite what I'm after. I think it's definitely a use case, and I think it's something that I'd probably like to look at. But I kind of want to break this apart into two things first, because I think this has slightly different nuances here, and I want to focus on those.
I think from our standpoint, if we're looking at actually getting this thing implemented, we actually have to understand both, because it's something where we're going to approach live snapshots at some point, and this is, unfortunately, it's overlapping. I understand that you don't really want to implement necessarily the use case where it's running afterwards, but we at least have to have an understanding of how that's done and how this how these things are related, at least. Does that make sense?
Yeah, okay, I understand. Okay, I understand what you guys are saying. Okay, so let me tell you my motivation. The reason I wanted to focus just on one is because I felt like I felt like the discussion was getting lost in terms of what we were talking about. So that's why I wanted to focus on one. I understand they're related. So I'm fine if we want to talk about them both together. And yeah, I mean, that's fine with me. And even as part of the implementation, that's fine. It was just kind of a discussion point.
So it's not that we have to implement it end to end right away. It's that from high level design, I think that we need to have a plan for how all these things are related. That's the best way I can say it.
Okay. That's fine. Okay, then let me, I'll just revisit this then, because this part at least specifically, because I got what you're saying.
Yeah, it's fine that you have it here. I would leave it here, but just we should add it as a goal, that we should at least have an idea on how it would fit in later, right? But it's okay that it's not a goal.
Okay, cool. Okay. All right. So then I think that's the first topic, I guess, is that kind of use cases and those three things. So, I mean, do we have any more discussion on that? Because I know we had some comments last time about some of the use cases, and is that clear? Kind of, does everyone understand what I'm trying to accomplish? Are there any questions about that specifically?
Well, I guess the use I hate to bring this up. We've been trying to cover it on the mailing list a little bit. It's unclear what we're talking about. Are we talking about a virtual machine instance or a virtual machine? It says virtual machine instance in this use cases, but what's the admin? I don't completely understand the end-to-end use case if we're looking at virtual machine instances instead of virtual machines.
Okay. So this could be my understanding. So the way I've looked at it is that I have looked at the virtual machine instance, and this is what I've considered my running VM. That's like how I'm using it in the language here. And virtual machine being not running. That's like how I'm looking at it. And so I'm not looking at it maybe the way you are with like the objects. So that's kind of my perspective on this, because running virtual machine being that's how you get the RAM.
Yeah. I guess I'm thinking about, okay, so somebody's using a virtual machine object. So the higher level object where you can start and stop it and all that stuff. I'm seeing this idea of a suspended or whatever virtual machine as another state, perhaps, to that higher level object. So you'd have a suspended virtual machine that's saved off completely. The RAM and everything is a state where you can restore it, but it's like suspended in memory and it's not actually running anywhere. It's not taking any resources in the cluster other than the storage resources. Like I can represent that in that same high level object, the VM object. But when we talk about virtual machine instance, I'm trying to represent it just as a virtual machine instance with other like save state and things like that. It becomes more disjoint, and I'm just unsure.
Yeah, I mean it's the same like I'd say with the virtual machine instance as such. There is no strong binding in any way on just on the virtual machine instance. It just references some stuff, and you have to keep these references, right, for restoring.
Exactly.
It's another object like you have with the virtual machine snapshot, where also there is no virtual machine anymore afterwards. There you also keep all the references externally extra.
So what do you see as sort of the relationship between the virtual machine snapshot API and the virtual machine API? Because some of the way I view it is sort of like they're very similar. And like the virtual machine API, there are sort of things associated that you can do with it, but it's generally a representation of a virtual machine that you can run.
What we should probably explore in that direction, when we also said that we want to have a high level plan also for a live snapshot later on, it can make sense to explore if, for instance, let's suppose you have a VM and we want to do a live snapshot, if you would also have to save the VMI definition to a degree to keep some information for it. And I don't know, explore this relationship a little bit for the live migration case, I guess. For the live snapshot case, I guess.
As I understand what a VMI is the running, I will say the running state of the VM. So in this case, you are shutting down the VM, or you pause or freeze the VM or take like some kind of snapshot of it. So it's no longer a VMI, because when you restore it, it's no longer a VMI. It will be a
currently
different.
we have more on it. Like it's a VMI is also kind of the equivalent of a pod. Like you can have different controllers. One of them is a VM, which adds some features, and the other one which we have is right now is the virtual machine instance replica set, which can create multiple running VMs for you out of a single entry point and manage it for you and scale it for you. And yeah, that's also there. So it's not just that there's only the virtual machine.
Okay, so I guess what I'm hearing is that, so there's sort of the two conflicting things. So I think I understand now what I think, David, you were talking about now with the virtual machine replica set. So so you have an API that can sort of, isn't necessarily a representation of a running virtual machine with a virtual machine replica set is kind of what I'm understanding. And then you have a virtual machine API, which is kind of similarly holds some of that ground as well. And just the virtual machine instance itself is a single representation. And so when we shut it down, it's technically no longer a VMI, Yeah, I think I understand that. I guess the thing that I'm missing though is like, so I guess maybe this is a discussion, the direction here. Like the one that I describe in this document is I'm talking about like, it's an API that I know Michael worked on for the snapshot. And I sort of view it as sort of a way that holds all the information of a formally running VMI. But technically I could see how a virtual machine is also can be considered a formally run a snapshot of a formally run API, or sorry, of a formally run virtual machine. And I just couldn't really reconcile the differences between the two, but it seemed like initially that the snapshot seemed to fit, but maybe I didn't explore enough into the virtual machine API.
The virtual machine snapshot is a point in time of that VM object.
Okay.
And it can be restored to that previous point in time. We're talking about restoring the VM object, the higher level object. It only works in the higher level object right now. So let's say it's like, think of it like a restore point for like your laptop or something, where you can restore it to the previous state. But it's still, that VM object is the stateful object. So there's not a concept right now of restoring a VMI exactly. You're restoring the VM, which in result, when you turn it on, becomes a VMI. Like the VMI isn't any state, it's just a running instance.
So if I would, so then maybe the path, well, okay, would then, let's, I guess we'll look at it this way. What if I, as a part of, just hypothetically, or hypothetical design, I guess, I took my virtual machine instance and as part of my save, I created a VM object and then I used the same API.
Yeah, that's possible. But what if that VMI was already supported by a VM?
Just use the existing object.
Sure. Sure. I mean,
okay.
something like that can make sense.
Okay.
Yeah.
Yeah. So
if you-
transforming a VMI into a VM is possible easily anytime, right? I mean,
Sure.
in theory, you can even just on a running VMI, which you directly posted, you can anytime create a VM object with the same name and it gets adopted actually.
I'm just curious how realistic will be this scenario where the vendor will be able to restore this virtual machine in their lab.
Do you mind if we cover that in like a few minutes? Sorry, I don't know who's talking. Do you mind if we cover that in a few minutes? And we just to finish like the kind of the API discussion here first, and then we come back to that. Is that okay? Because I think that's I do want to answer that too.
Okay. So I think we can explore this direction of a kind of forensics debug flow where you would then just transform any VMI into VM as part of a snapshot. I wouldn't see anything speaking against it.
Okay.
I guess David also brought up this VM replica set instead of a VMI replica set. I can see the benefits of that too. Also see the disadvantage of blurring the difference between more manual managed and more automatically managed instance, but could also be a valid path forward exploring.
It's
Okay.
strange when we look at the virtual machine instance replica set. The thing that's strange is how do we represent individual state of VMIs? So right now it's all ephemeral. If somebody has a PVC that they have in their virtual machine instance replica set, it's read-only, and the ephemeral state is stored on disk with the VMI in that container. So when we talk about taking a live snapshot or a save restore point or something like that, there's nothing to, we'd have to somehow get that local storage onto something persistent. Like it doesn't.
Well, I mean, that's what you have to do anyway. I mean, what you have with this shared storage is that you anyway write into overlays, right, in your VMs. So you have a read-only base image, which is in the PVCs. So you can just snapshot it anytime with including the overlay.
Where's the overlay get put?
You have to create new PVCs like for the snapshot, like you do for VM. You can't use the same there either.
Okay. So, yeah. Okay. I see. So you would create a VM for the a PVC for the overlay.
Yeah. not necessarily for the overlay, maybe also for emerged content. I guess we have to do the same. All I want to say is it's the same like for the offline snapshot flow. You basically have to create a new PVC and put the data in there for the snapshot.
That's really tricky. So we're kind of looking at hot plug too here, in order to be able to dynamically create a PVC, attach it to that pod while it's in that suspended.
Well, there is the
pod.
snapshot. I'm not sure we're talking about the same thing here. There is the snapshot and restore API for PVCs, right? So you basically know at the time point where you do the snapshot that you can safely do the snapshot. That's the main thing.
Sure, but
I'm not sure how far
the ephemeral overlay is on local disk.
Yeah. So I'm not sure what we support right now. Well, not necessarily. It can as well be on a PVC, and you just
How?
use
With
a
a virtual
read-only.
machine instance replica set, would you do that? You can't do that today, can you?
Sure, you can. I mean, you can create a read-only PVC. You can use our ephemeral disk, which creates a backing file for that read-only PVC.
That's what I'm talking about. That ephemeral disk runs on local storage.
Yeah, I don't know what we support, if we support that already on offline snapshots.
There's not a per VMI
I mean, there's no overlay.
persistence when we talk about the virtual machine instance replica set. Sorry, we're getting on a tangent here. The point I'm trying to make is, Ryan, if you end up moving to something like the virtual machine instance replica set, then we're going to have issues trying to even save and restore a VMI, because a portion of that VMI's data, the disk, is on an overlay that's on local storage. So you might have a read-only PVC, but the only thing that we support right now is that read-only PVC with a local ephemeral overlay. So you wouldn't even have anything to save exactly.
Yeah, I guess, but it's the same with VMs. If they would use ephemeral overlay,
But
it's a
you
matter
have
of
options with VMs. So you could create a per VM, like the daytime templates, whatever, could create a per VM persistent volume claim. So then you'd actually have.
You can get the same to the replica set controller. I mean, that it does.
So,
Right.
so this like, would you say, I mean, is this something that like with the virtual machine instance replica set, is this something that sort of, I mean, is there a way to sort of, that we can make it, like incorporate this as part of like I don't, like how would I get, like is it was kind of what you're telling me, is that like there isn't really a way we can make this work, or is it that we sort of need to do some major changes to make it work? With,
so I guess it's hard to tell what you actually try. It really depends on what you try to achieve. The virtual machine instance replica set has some advantages when you think about ephemeral VMs regarding to overhead and complexity, because you can use you can use, I don't know, a container disk and just write in overlays or whatever easily. But on the other hand, not everything may be there yet, like getting a PVC pair VMI from the replica set, right? You can only upfront define what you want, accessible for all VMIs, basically, except for local storage stuff.
Okay.
But it's how it is today. I mean, yeah. And I mean, I guess you have the same thing if you would think of a VM replica set which uses VMs, and you use a container disk, you have the same issue, because the container disk, you write into an overlay. So with anything using a container disk, it needs to work with this kind of implementation. It doesn't matter if it's a VMI or a VM.
Okay, I guess, so let me, I don't want to take too much time, I guess, on going through this. I mean, would one of you guys be able to like maybe summarize this in the doc? I don't know, can you do me a favor? Or maybe, I don't know, like, is it on the thread? Like kind of, because I do want to capture this, I guess maybe as part of this as something like a caveat. And then, but I think like, and then kind of move on with, I guess, some of the other design stuff. Is that okay with you guys?
That's fine. I think that I think we can get together offline, or let's just have a meeting to discuss this with whoever's interested, and let you kind of continue with your presentation here. And I think that we can sort all this out in a more focused setting.
Okay. I'll make a note. Okay. All right. So I think to kind of conclude here, what so I do like the idea of, okay, we go from VMI, we follow the chain of going to VM and then VM snapshot. I don't know. Is there anyone object to that? Like, is anyone think that's like the wrong path? I think that seems reasonable to me. Then
I don't necessarily object to the idea of going from a VMI to a VM. The thing that gets strange is when we already had a VM associated with that VMI. So
okay, so maybe some details I need to explore there then.
Yeah, let's talk about when we have the focus discussion about perhaps why VMIs are only in use for your use case, and maybe understand kind of. I'd like to understand better why you've approached this the way you have.
Okay.
Yeah.
Okay. All right. I think we can talk about that further then separately. Okay. Now, I don't know who was talking earlier, but let's dive into the use case.
Vladik was it?
Vladik, yeah. Do you want to say what you said earlier?
Yeah, I'm just trying to understand what problem are we solving? I mean, even if we'll create a VM or anything like this, it will still stay on this system, on the system that we actually took the snapshot. And what you're describing in the use case is that you will want to export this, and then someone on another system with another cluster, with another set of nodes, will have to restore this. And I'm not entirely sure how realistic is this. And
so the general sort of principle I'm kind of looking to apply is that is sort of that I could have that once I take this virtual machine, it's now mobile. Now, I guess you could say, like, how could I take this virtual machine that's sort of snapshot in a PVC that's in a CRD in a Kubernetes cluster, and then offload it, put it on a USB stick, and move it to, like, you know, I don't know, another state, and then plug it into my home lab or something. Yeah, I understand that. Like, I guess that's not necessarily like what I'm after. It's more like the idea that the mobility of this virtual machine can go beyond just where it currently sits on the current host that it's in. It could somehow go, I don't know, slightly to a different namespace at the very least. I mean, possibly, I don't know, like the other side of that, I think sort of is not really like what, like I want to cover, like, because I think, you know, maybe there can always some sysadmin stuff I can always work out, but mostly the idea that I can take it offline and I can move it. Like, it is snapshotted in this place that I can move it around in an object.
I'm just saying that when we are saving and when we're saving memory, we need to know what kind of CPUs were used, you know, specifics of hardware. So basically, when you restore this, it has to be restored on the same kind of a node. And then what I'm trying to get at is that maybe what you're after is really some kind of a import-export or export-import. And maybe that's what we need to really implement.
Well, I mean, to me, maybe it might. To me, it just seems might be like if we go down the road of like, maybe someone correct me if I'm wrong. Like if you take like the virtual machine and you have it stored in an object, and then you're literally offloading it out of the cluster. Like, maybe that sounds like kind of what you're implying, like export. I mean, that's like, I guess I don't know if that seems, it seemed like it'd be in scope of KubeVirt. I mean, I guess I would expect sort of like a sysadmin to sort of handle that. I'd sort of like, I mean, what could you do in KubeVirt to sort of make that reality?
So can I just ask, do you have like a reference other system that does it? So that will make it easier, maybe.
Don't we have import-export in Rev?
Yeah, but import-export, I think, is only about I don't think it includes RAM, if I'm not mistaken. I mean,
so RAM, maybe we can save it as a dump, and then.
No,
I mean, the use case here is that something happened with the virtual machine, right? And we want to debug it.
yes.
So there are two situations here. We want to the same image, the same kind of setting we want to restore somewhere. And then on the other hand, we have a RAM. So RAM we can save as a dump and provide it together with the import export. And dump can be analyzed separately. But then for the administrator or for somebody who wants to debug a specific card on a specific image that he will be able to restore in his lab, he needs the way to import an image and then restore and use it with a similar card, for example.
Yeah. So my question was, is this idea coming from an existing system that, or existing solution on a different system that supports it, or is it something totally innovation here that we want to try it on KubeVirt? This is my question, I guess.
I don't. Yeah, I mean, I'm not sure I have the answer. I'm not sure I have the answer to that. I think yeah, go ahead.
I just thought that you are coming with this from something that you already had in a different system, and you exercise it, and now you want it here as well. But
sorry, I maybe I missed it. Okay, so so there is, yes, like this is sort of this is the case in an existing system. Yeah, it's sort of not like I don't know. I guess my perspective on this is that like I could think of ways to get like the files off. Like for me, what I'm after is like getting the state stored. I think I probably could figure out how to get the state, if it's stored as a file, off. Like that's where, like I think that's sort of where like I'm sort of drawing the line right now, and I don't want to go past that.
Yeah, but you are using, so this is, if for example there is a existing system or existing solution, Rev, OpenStack, I don't know, anything else, BusyBox, something that does it.
It's and then it's OpenStack.
Sorry.
Or maybe it's like homegrown, but I know it's at least based on OpenStack.
Okay, so that was my question. So if it exists in a different place,
yeah,
we can try to investigate that reference and see what is done there and what are the limitations there, and then we can consider importing it here or seeing where we can do the same or not.
Okay.
Because the scenario, I do understand it, and I do understand, I think, what Vladik said. But it sounds like to something that it should be common to do. Like I'm working on something and now I have a problem. The customer service of that appliance wants to debug it, so I can just take a snapshot or something similar and send it to him, and he can evaluate it. Obviously, it cannot work on everything. For example, if you have hardware dependencies, or like your CPU is not emulated or something, uses some kind of is based on your hardware, that will be impossible to restore. But maybe we can add these limitations, I guess.
Okay, I made a note for myself. I'll can take a look at OpenStack and maybe if they can get a few links to like export or something. See what they have. Okay, thanks, Vladik. Okay, is there any other questions about, so we're still at use cases and the section? Any more comments about that?
I think it's the initial idea is pretty clear now.
Okay.
We can probably refine more on what to do with it than like Edward and Vladik hinted a little bit. Like once you have snapshotted it, what would be the kind of operations you would want to do with it? Like Vladik mentioned core dump, right? You may want to add starting it in the same namespace or another namespace. Another namespace is tricky, but anyway, to live debug it maybe with similar devices, or I don't know, stuff like this. That we have because it kind of it's an impact, I guess, on implementation.
Okay. Yeah, those are things. Yeah, that we can add on over time. Okay. All right. What was the second thing? Now I forgot. Device management. Okay. So I added another section in here about. Oh, actually, there's sort of two things in here. So last time there's a question about whether, based on the flags that we could provide, what will happen to the virtual machine. So I just added a section with the two functions that I found in KubeVirt that do the save, and here are some examples of what they do. So I'll leave those there, whatever, if you want to read them. But the main thing I'm looking for is this, and then at live, doing live at a later point, we can do this, and then there's obviously a bunch of other things that we could do. So that's cool. All right, devices. So one of the things that I've had brought up or mentioned a few times here is devices and what happens, when you save, restore, and you have devices attached. So one of the things is, and Dan Baron J was the one who commented on this. It's somewhere on this. I think it's below. And sort of the expectations, what happens when you do a save. So the expectation is that you'll have to detach the devices before you can do the save. And it's basically the same as in live migration. That's what I was reading. And essentially what we need to do is do some sort of hot unplug of the devices. And from what I could tell, Kubernetes does not support this, but I think that's okay. This is essentially hot unplug with Kubernetes, since Kubernetes makes those devices available to the pods. Hot unplugging would be removing them from the pods. So one way around this would actually, since we have the Virt launcher there, maybe we can have the Virt launcher sort of call it delivered and say, hey, just unplug these devices. I call this a software unplug. I don't even call it whatever. But I think this makes sense. We can make it so that save operation is triggered, and sort of the contract would be that save is triggered. Virt launcher is going to go unplug those devices with the expectation that this pod is not long for the world and is going to be terminated. And this is probably actually a good place, like we can even discuss live as well, because this also has a different path, but not something I have here right now. But essentially that pod's not long for the world. It gets removed. Those devices are freed up on the pod, and the save can execute without a problem.
Brian, just have a question.
Yep.
I mean, what kind of benefit is it for you then? For example, you were debugging some kind of a system with the GPU attached, and it was misbehaving.
Yep.
And then in order to save the memory and restore it later, for example, you will need to detach this GPU, and then. So, I mean, is there still a benefit? Because, I mean, the system doesn't run, I mean, the memory snapshot that you're taking, it will be without GPU.
Yeah, so my understanding is that, yeah, you're right. It is without GPU. I don't think it affects the use case. I mean, I believe the operations or whatever. It basically, like, the idea is that the devices need to be shut down so that nothing, I guess, I don't know, Liver maybe doesn't understand what the internal operations of it are, so they need to be removed. So I guess I don't know, I mean, I don't think it would affect the running operations of the VM or like of the RAM as part of I don't know. I mean, that's a good question. I think that's one I can maybe take.
I think the minimum that, I mean, in this case, in my opinion, the minimum will be that if you have such devices attached, will be not to allow this operation to happen at all. And if you want to get more sophisticated, you can do this unplug thing. But then I agree with Radek that if you restore it on the other side and you don't have this hardware, then it will probably blow up. I mean, the whole VM the OS there will crash because you don't have I mean, it before it tried to access some place, and now you restore it and there is no such address anymore. So
well, that side of things, I think would be okay. I'm going to talk about it down here, but the restore side. But I think like the way I heard what Vlad said was saying is that what is this virtual machine exactly like? Is it in that sort of problematic state if we detach the device, right? Is that what you're saying? Like, is it actually, are we actually able to sort of say that we can do forensic analysis because the save we just did was involved removing the device?
When does the device get removed? Is it after the pause?
I don't know the answer to that.
That would be my expectation, but I don't know. I would expect that it gets paused. We remove devices. I'm not entirely sure why that needs to happen still, but that's okay. And then we snapshot, and then when we restore, you're kind of putting everything back the way it was, and then kind of hitting the button to unpause it. So
Yep.
I guess I'm unclear.
No, you assume that someone will is able. I mean, you assume that the restoration, you have all this hardware there.
It has to for it to start. You're not going to get the pod unless it does, because the pod's going to have the requests for that GPU and everything.
David, the only thing that, I mean, the reason for this is that some of the memory that the VM is using is being stored inside the device. So the device state and some of the caching and some of the things that are going on at that particular time, it's being stored in the device.
You're
If you
totally
don't
right.
have that
Oh my
specific
gosh.
device
Right.
with that cache, I mean, it will not.
Yeah.
You're
So
right.
that's what I'm asking. What's the benefit of? Is there still a benefit in doing this save and restore if we don't have that information? If we don't have this device saved?
Yeah, but like most, like let's take. It looks like to me like 99% of the market is not about this kind of hardware acceleration devices. So,
But Ryan says, Ryan,
yeah.
I have a feeling this use case is a little bit more important to you.
Yeah.
That's something really important to understand. I would go back and try to gather what with the GPUs, if you're even able to save the state of the GPU in the way that you need to restore whatever app you're running.
Yeah, I do need an answer to that, because that is true. Because I mean, yeah, I'll be able to find that out. Yep, that's a good point.
It's also a problem in migration, if I'm not mistaken, right? It's the same problem.
Yeah, although NVIDIA are working on a solution together with Reddit for live migration with vGPUs. I don't know about GPUs themselves.
It seems like whatever solution worked out for NVIDIA for live migration, the same mechanics would be involved with this save restore, because you're having to take this the state of a GPU, whatever it is, and transfer it somewhere else, right? So we'd have the same mechanisms.
Yep.
It's just not there yet.
Right, exactly. Yeah, Ryan, you got to figure that one out before we can even really do much of anything.
Yeah, no, that is definitely a critical point there. Yeah, I didn't see that. So yeah, because otherwise, yeah, we can't even do live, can we? Yeah, we can't. Yeah. Okay.
So for your use case, what would you still have the same benefits if you shut down the VM entirely and did an offline snapshot? Like, I'm trying to understand how important is it that you capture it right at that moment, like the live state, everything. Is it possible to reboot it and get back into that state? Or I don't fully understand the applications that you're running.
No, so it's specifically, yeah, I mean, once you shut it down, you sort of, the idea would be that we lose where the execution is. Like a good example be like, I mean, this kind of sums it up. I mean, like what I have here, it's really that, yeah, you have your virtual machine running. I mean, you can say like it's a game or something, and it's behaving wrong, and we need to diagnose it. So
Okay.
we need to pause the game essentially, and then move it, figure out what this person was doing that's causing this VM to suddenly consume a ton of memory, like it's mining Bitcoin or something.
I see. Yep.
So yeah, when you need, so the GPU cache and memory, everything is important here. Okay, I think that's sort of the that's probably, yes. I'll take the action item, come back with that for next week. I think that's probably the most critical item before we can even proceed with any of the other stuff. So
Ryan, out of curiosity,
Yep.
Are you mostly interested in full GPU path through, or what Vladik mentioned, vGPU path through?
Both.
Both, okay.
Yeah. Yeah. Okay. I think that'll probably be all for me. I think, yeah, we don't need to, what was the last PVCs? Yeah, we can kind of talk about that at another time then. Let me take this, this item and kind of do some more investigation, and then we can talk about some of the other items. I think there's probably even more topics we can cover too as well. As long as I get the, let me get some more information on this and get back. All right, I'm gonna stop sharing.
Okay.
All right, thank you.
Well, thank you. Well, I mentioned at the beginning that we only had one agenda item. Well, that was quite an item. So thank you for the discussion. I learned a few things. Anything else on that topic? To summarize, there are those action items to take forward between now and next meeting. Anything else? No? Any other topics that are not yet in the agenda?
Hello.
Hello, Fabian.
My audio is probably. We could hear you.
Yeah. Well, not now. You are on mute, apparently. Let's just wait a few seconds, but Fabian, we heard you, and then you appear to be on mute now.
Oh, it looks like Fabian didn't want to say anything.
Ah, okay, okay. Ah, okay. So that's a okay. Then, if no other topics, we'll close it here. So thank you everyone for attending, and I'll hope to see you next week.
Thank you. Bye.
Thank you.
Thank you. Bye.
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 Thank you. Bye.